so calculate the tension of rope P. Okay, so calculate the tension of rope P. Okay, so you have to draw the triangle using the sign of cos, right? So this is the weight here. Okay, so the weight is going downward. Okay, okay, and then it's already give you the mass, right? So the mass of A and B. So if you add is 0.7 plus 0.3 is 1. Okay, but and then you change to Newton. So should be 10 Newton here. Okay, and then the next thing you draw the triangle. Okay, so only take half of it like this. Okay, so this one should be 60. Okay, so this is the weight. Okay, so the weight is actually we already calculate 10 Newton. Okay, and then P, this is the tension P, right? This is the tension we already draw before. Okay, so this is the T. So how you want to find T? So you find the relationship. Okay, so this one we call it as a opposite. Okay, opposite. So this one is 90 degrees. So this is called as a hypotenuse. Okay, so this one we use sine. Okay, so sine. Okay, sine 60. Okay, is equals to. Okay, the opposite here is 10. Okay, and then the hypotenuse here is the T, the one that you need to find. Okay, right, and then you try to solve it. Okay, so you got the T is 11.54. Okay, but you have to remember actually the T is a 2T. Okay, because you can see there are two tension here. Okay, P and Q, and the rope is balanced by these two tension. Okay, from P and Q, and then after that you have to divide by 2. Okay, because you just only one, the T here, only one T. So if you divide by 2, you will got 5.77. Okay, Newton. Okay, so this is the answer for question B, right? So you just use cos here, okay, or sine. Okay, depend on the side, which side is given, whether opposite, hypotenuse, or adjacent, right? Okay, so next we move on to the next question. Okay, so I hope you already copied this one. If not, you can watch. I already record this video. I will put in the YouTube. Okay. Okay, so we move to the next question. Okay, so if the rope, if the rope Q is cut, what is the new tension of rope P? Okay, so let's say we cut, we cut the rope Q here. Okay, so now the only one rope, that still hang, that is P. So now only means the P, so the tension will be only one here, P. So how you want to find P, so you just use the weight here, so 0.7 plus 0.3, so you got 1 kg, so 1 kg, 1 kg times 10, so the answer should be 10. Okay, so the answer should be 10 Newton at least. Okay, because now the rope is only one tension here. Okay, only one tension that acting. Okay, for the object. Okay, so the weight is become only one tension here. Okay, next one. Okay, diagram 9.1 shows a velocity time graph for bus A and bus B, traveling from Kuala Lumpur to Penang, both buses start their journey at the same time, so, said here, what is the meaning by velocity? So, velocity is the rate of change of displacement, rate of change of displacement. Okay, so this is the first question. Right, the second one. So using diagram 9.1, compare the velocity of bus A, okay, and bus B in the first hour, the gradient and area under the graph. Okay, state the relationship between velocity and acceleration and deduce the type of motion during the last 2 hours of travel. Okay, so you can see the compare the velocity of bus A and B. So you can see the bus A have the high velocity compared to bus B. Okay, and then if you compare the gradient, of course the gradient of bus A is higher. Okay, and then the next one, area under the graph. So area under the graph for bus A is higher. Okay, right? So this is the answer for question part 1. Okay, this is for the part 1. Then the part 2 is state the relationship between velocity and acceleration. Okay, so the higher the velocity, the higher the acceleration, and deduce the type of motion during the last 2 hours of travel. So the last 2 hours means from 3 to 5. So you can see the velocity is not change, right? So means the velocity is constant, or you can say it has a zero acceleration. Okay, so you can put zero acceleration here also can, or you can say the velocity is uniform. Okay, both also can be acceptable. Okay, so this is the answer. So in exam, I want you to put the point in the point form like this. Okay, so I know that every point is actually for 1 mark. So you can see here's 5 marks, so means 5 point like this. Okay, so this is question AC for number 9, right? And then the next one, okay, so diagram 9.2 shows a graph of displacement against time for a car with passenger on board. Okay, so from the graph, explain the type of motion of the car throughout the journey and what is the total displacement travel. Okay, so you have to describe, right, the time. Okay, so from 0 hour to 3 hours, okay, so the car move with uniform velocity. Okay, because you know the graph is displacement against time, right? The gradient is actually equals to velocity. So here you can see if we draw the triangle here, okay, so if you draw a triangle here, so you can see the triangle is in the same size, right? So if you draw a triangle, the triangle will be in the same size. So means the velocity is same since the gradient or the size of the gradient also is not changing. Okay, so wait. Okay, so from 0 to 3 hours, the car move with uniform velocity. Okay, and then from 3 to 5 hours, you can see the displacement is same. Means it's only stay like 120 kilometer. So it means the car is not moving. Okay, so the car is in stationary, or you can say the car is not moving, right? And then from 5 to 8 hours, okay, the car move in uniform velocity. Okay, but opposite direction. Okay, but opposite direction. Okay, and it until it reach initial position. So you can see at last, okay, at 8 hours, right? So the displacement is zero here. Okay, at 8 hours, this displacement is zero here. So means it's come back to its initial position. Okay, so and then the last one is the total displacement is zero. Okay, right? So from 0 to 3 hours, move with uniform velocity. Okay, how do I know it's uniform velocity? I have to remember the gradient of the displacement against time is actually equals to the velocity. So if you draw the triangle here, so the size of triangle is same, right? Means the gradient will be also same. Okay, so means the velocity also same. Right? This one, the displacement is same, okay, does not change, so mean it stay at the same position, right? So mean the car is in stationary. Okay, and then this one it become it going down like this, but if you draw a triangle, the size of triangle is still the same, so mean it still move with uniform velocity but in opposite direction. Okay, and then when it comes zero like this, you have to know it means it's already reached its initial position, so the total displacement is zero. So 4 marks, right? 1 mark for 1 point. Okay, Alright, next question. Alright, diagram 9.3 shows an old bicycle. So you are required, right? You are required to modify the design in diagram 9.3 so that the bicycle can be used in a mountain bike challenge 2017. Okay, state and explain the modification based on the following aspect. Okay, so the first one is system to assist in climbing. Okay, and then the material for the frame. Okay, and then the tires and others. Okay, so the first one, if you want to the system to assist in climbing for a bicycle, usually we use a gear, right? So you have a gear, so why? So easy to climb high mountain. Okay, and then for the material of the frame, so low density. Okay, and why? So light. Okay, you can say also strong material, long lasting also can. Okay, and then the tires should be thin tires, so this one to reduce the frictional force. Okay, since the surface of area also decrease, so the frictional force also will be decreased. Okay, and then the seat should be higher than handle. Okay, this one is to reduce air friction, right? And then the next one is a soft seat, so this one is comfortable to sit. Okay, so this is the characteristic. Okay, so let's say you have another answer. Okay, so maybe you can give to me. Okay, let's say you've already answered. Any other answer? Alright, I think no. Just open your chat. Sorry, just open your mic if you want to talk. Okay. Alright. So this is the answer for this question. Okay, so we move on to next one, right? So diagram 5.1 and 5.2 shows how two different spring P and Q behave when the same load is hanging at rest from each spring. So this is spring P and this is spring Q. So you can see the difference here is actually the diameter of the spring. So this one is much smaller than this one. Okay, so the next question asks, both spring P and Q are elastic. So they are made from the same material with the wire of the same diameter. Okay, so the diameter of the wire is same. Okay, however, the diameter of coil of spring Q is bigger than that of spring P. Okay, so the first question, what is the mean by elasticity? Okay, so the elasticity is the ability for an object to go back to its original position when the external force being moved. Okay, so this one is like a spring. Okay, so if you put the load in the spring, so the spring will extend, right? So and then after that, you move the load. So what happened to the spring? It will go back to its original position. So that's what is meant by the elasticity. Okay, for B, using diagram 5.1 and 5.2, compare the forces exerted. So since it use the same load here, okay, so mean the force also must be same. Okay, force exerted is same. Right, the next one, the spring constant. Okay, so the spring constant for diagram 5.1 is higher. Okay, why? Because small diameter. Okay, diameter of the coil here, okay, is much smaller. So you have to know the smaller the diameter of the coil, the higher the spring constant. So it means it become more stiff. Okay, so the spring constant. So the spring constant for diagram 5.1 is higher. Okay, sorry, this one this one is wrong. Okay, I change the answer. So the extension of the spring, okay, the extension of the spring for diagram 5.2 is higher. Okay, so the extension of diagram 5.2 is higher. Okay, just compare. Okay, using the diagram. Alright, the next one, relate the force constant to the diameter of the spring. Okay, so The smaller the diameter of the coil of the spring, the higher the force constant. Oh, actually this one is a spring constant. Okay. The smaller the diameter of the coil of the spring, the higher the force constant. So you have to remember the factors that are affecting the spring constant, right? First one is the length of the spring. Okay. The shorter the length of the spring, okay, so the higher the spring constant, so means it will be more stiffer. Okay, and then the next one is the diameter of the coil, right? The smaller the diameter of the coil, okay, the higher the spring constant, so mean the spring will become more stiff. Okay, and then the next one is the thickness of the wire, right? So the higher the thickness of the wire of the spring, so it will become more stiff. So mean the spring constant will also increase. Okay, so there are three factors. Okay, and the last one is of course the material lah. So the material usually the chrome is the higher spring constant. Right, for D, so this is the calculation. So its extension of spring P in 6 cm when it used to hang an object of 100 gram. What is the spring constant of spring P? So this one we just use the formula F is equals to Kx. Okay, F is the force that been given and that is given to the spring. Okay, so we put the object here 100 gram. So you have to change this to kg first, right? And then you have to multiply to 10. Okay, change it to Newton. So 100 divided by 1000, change to kg, and then multiply by 10, okay, to change it to Newton. Okay, and then K is a spring constant. So X here, so 6 cm, right? So remember, change it to meter. Okay, change it to meter. If you want to change, it's okay. But this one, the unit should be NCM negative 1, right? So for me, I change it to meter. Okay, so then I just divide. Okay, so I got 16.67 N over M. Okay, so this is the answer for question D. Alright, so the next one, okay, diagram 1 shows a measuring instrument is used to measure the flow rate of charge in a circuit. So what does it mean by accuracy? So the reading from measuring instrument that closest to the actual value. Okay, so this is the meaning of accuracy. Right? Okay. Next one. Okay, state the type of physical quantity measured by the measuring instrument. So this is ammeter. So ammeter usually they measure current, and current is actually scalar. Okay, scalar means only have a magnitude. Okay, for vector have magnitude and also direction. Okay, right. Next one. Okay, tick the correct reading for the measuring instrument. Okay, so let's see the ammeter first. Okay, so this one is 200 milliampere. Okay, so 200 milliampere. So we have to change, right? So 200 milliampere, 200. Okay, milli is 10 power of negative 3, right? Okay, so this one you change to standard form. So 2 times 10 power of 2, right? Multiply 10 power of negative 3. So you solve it, you got 2 times 10 power of negative 1. So negative 1 should be 0.2 ampere. Okay, so that's the answer. Right, 0.2 ampere. Okay, so let's go to the next slide. Okay, name the physical quantity measured by instrument. So the answer should be current. Okay, so I noticed some of you, okay, they have a problem to differentiate, right? What is the physical quantity? What is the magnitude? what is actually the unit. Okay, so some of you, if the question asks name the physical quantity, you will put the unit here, ampere, right? So no, physical quantity means the name. Okay, the name. What is that? What did actually you measure? Okay, so for this one, you measured current. Okay, but if they ask you the name, give the SI unit, so then you put ampere here. Okay, so this one I give you the example how to differentiate. Okay, what is a physical quantity and what is actually unit. So the physical quantity is actually the name of the thing that you measured. Okay, and then the symbol, so this one is L. Okay, and then the number here is a magnitude. Okay, and M is the unit. So this one is actually meter. So if they ask you the SI unit, you put unit here, meter. But they ask you the physical quantity, means what is the type of measurement that you use, that you read. Okay, that you read. Okay, so we move to the next one. Okay, and I like to remind you, right? So for this question, like especially the calculation one, okay, I still like when I mark your paper 3, okay, I still notice that some of you still using fraction as the answer. Okay, I told you so many times, no fraction, no fraction. Okay, no fraction. Okay, so please, right, remember, no fraction. Okay, don't give answer in fraction. Okay, don't give answer in fraction. Okay. Can you give me some time? Wait. Okay. Sorry. Right. So we continue. Okay. Mm, okay. So number 5, right? So diagram 5.1 and 5.2, okay, shows the arrangement of two similar springs for a baby cradle, okay? And then the first question is state the meaning of elasticity. So this one is actually already answered, okay, before, right? So the ability of for an object to go back to its original position when the external force be moved, okay? Alright, so this one is a comparison question. So compare the spring arrangement. Okay, so you have to state for diagram 5.1. So you arrange it in the parallel, sorry, in the series. So diagram 5.2 is in parallel. Okay, so this is the answer. And compare the extension of the spring. So the extension of the spring for diagram 5.1 is higher. Okay, and then next one. Okay, state the relationship between spring arrangement and the extension of the spring. Okay, so this one you have to state what happened to when you for when the what happened to the extension. Okay, if you put it in the parallel or you put it in the series. So usually the parallel with spring arrangement will produce the lower extension compared to the series spring arrangement. Okay, so this is the answer. Alright, the next one state the relationship between spring constant and the extension of the spring. Okay, so the higher the spring constant, the lower the extension of the spring. Okay, if you don't have enough time to copy all the answer, don't worry. I'll put this one in the group. Okay, in the Google Classroom, so you can refer to it and copy the answer. Okay, the slide. Okay, the next one, explain another way for the spring of the cradle in diagram 5.2 to hold a child with a mass of 15 kg. Okay, so this one you can use the smaller diameter of spring, okay, to increase the spring constant. or you can say you can use a shorter spring, okay, to increase the stiffness of the spring, okay. Or you can say use a thicker, okay, thicker wire of the spring, okay, so to increase the spring constant. Okay, so you can use the three factors that I give just now. Okay, and name the laws. So this one is actually Hooke's law. Okay. Okay, so next slide. Okay, diagram 11.1 shows a spring used on the brake pedal of a motorcycle. Okay, and then it said here, what is it mean by elasticity? So I will not discuss this question because we already discussed it twice, right? So you can refer to the slide, okay, before here. Wait, yeah, okay. You can refer to this answer, okay. Alright, so I move to the next question. So explain how the spring in diagram 11.1 can return the brake pedal to its original position. Okay, so when the brake pedal being pushed, okay, the spring will expand. Okay, the spring will expand. Wait, it's not expand. Should be spring will to its original position. Okay, I change it. When the brake pedal being pushed, the spring will compress, right? Okay, and then the spring particle will move closer. Okay, okay, so move closer. Repulsion, not attraction, repulsion. Okay, so I explain again. So when the brake pedal being pushed, right, so the spring will be compressed. Okay, and then the spring particle will move closer. Okay, so when the brake pedal is being released, okay, the force of repulsion between the spring particle will increase. So it will push back, right? It push back the spring particle to go back to its initial position. Okay, so this is the answer for A2. Okay, next one. Alright, so this one based on diagram 11.1, the original length of spring is 8 cm. So when a force of 100 Newton was placed on it, the length of spring become 18. So calculate the spring constant. So write your answer in SI units. So mean you have to change to meter. Okay. So F is equals to Kx, right? So the F already given 100 Newton. The K you want to find. Okay, so the original length is 8. Okay, so but you when you put the 100 Newton force, it's become 18 cm. So X is the extension. So you just minus 18 minus 8. So you got 10 cm. Okay, and then you change to meter. So 10 divided by 100, you got 0.1. Okay, and then you just divide. So you got 1000 and m negative 1. Okay, so because you want to you want the answer in SI unit, so means the cm must change to meter. Okay. Alright, for the next question, the length of the spring becomes 12 cm. Okay, become 12 cm when a force, okay, when a force of x n is placed on the brake pedal. So calculate the value of x. Right, so this one you need to find the F. So same, still use F is equals to Ks. So F you want to find, okay. K we already K is actually, I think it is 1000, right? Wait. Did I calculate it wrongly? 100 divided by 0.1, yeah, correct. Okay, so means that I took the calculator first. So 1,004 divided by 100 times 1,000. Okay, so the answer should be 40 Newton here. Okay, sorry. Okay, so F is equals to Kx. Okay, so 1000 is actually the one we already calculate before from here. Okay, and then the extension is 12 minus 8, right? So 12 is the extension, 12 is the length after you put the force, okay, but the original length is 8 here. So I minus 12 minus 8 to find the extension, and I divide by 100, okay, to change it to meter, right? So you got 40 Newton. Okay, so that is the force. Okay, and then they ask you to find the mass. Okay, so using W is equals to mg. W is 40. Okay, M is the one that you need to find the mass. So M is actually 40 divided by 10. Okay, so you got the answer 4 kg. Okay, right. So if any question, you just open your mic. Okay. And ask. So sometimes maybe I cannot notice in chat. Okay, so we move on. Okay, to the next question. So diagram 11.3 shows a gardening tool, okay, called pruning shears. So the pruners are essential for many cutting jobs, especially to cut stems and branches. Okay, so asking you to choose, right? So which one is more suitable to be used to cut the bigger stem and branches? Okay. So give reason for your choice. Okay. So this is the characteristic. They got 4 types P, Q, R. So the material you can choose whether iron or steel. The shape may be straight or curved, right? And then the material, and also the last one is the presence of the spring. Okay. So the first one is the material. So the material which we should choose steel. Okay. So material for the blade is steel. Why? Because it's long lasting. Okay, and then the shape of the blade, okay, should be curved. Okay, should be curved because easy to cut. Okay, and then the next one is the material of the handle. Okay, so the material should be aluminium alloy coated with the thermoplastic rubber. Okay, so why easy to grip? Okay, so this one easy to grip. Right, and then the last one is the spring. Okay, whether you should have a spring, okay, between the handles. So the answer should be yes. Okay, weak spring. Why? Because not easy to snap, easy to come back to its original position. Okay, because it's elastic, right? So the last one I choose S because steel blade, curved shape of blade, okay, aluminium alloy coated with thermoplastic handle and have spring, okay. So remember after you put all the characteristic, you have to choose and also copy back all the characteristic here, okay. Okay, next one. Diagram 2 shows a man pulling a sack of fruit upward using a pulley. So he pulled the sack with a force of 50 Newton. So the force act on the sack of fruit are equilibrium. Okay, so this one you have to notice. Okay, underline equilibrium here. Okay, so mean that the upward force is equals to the downward force. The net force is 0. Okay. Right, the next one, the next question asks you to state the meaning of the force in equilibrium. So when the force in equilibrium means the net force acting on the object is 0. Okay, is 0. Okay, is 0. Okay, the next one, based on diagram 2, okay, draw 2 forces that acting on the hanging sack. Okay, so this one should be, okay, this is the tension. Okay, and then this is the weight. Right, when you level a weight, okay, when you level a weight, make sure it's on the center of the object. Okay, so you cannot simply like put it like this. Okay, this is wrong. Okay, cannot. Must be at the center of the object that is going. downward. So you label it W. Okay, so this is the two forces that acting on the object. Okay, next one. Okay, the man give a pulling force of 50 Newton to avoid the sack fall down. So what is the value of the downward force that mentioned in B? Okay, so since you know that the force is same, right? Force in equilibrium means the weight is actually equals to the tension. So to prevent it, so it cannot fall down. Okay, so the force, the value of downward force mean will be same as the weight or same as the pulling force. So the pulling force here is actually equals to the weight. Okay, so the pulling force is equals to the weight. So the pulling force is 50 means the weight also must be 15 because it's in equilibrium, right? Okay, for B, for number 2, if the rope is cut off, what will happen to the velocity of the set? So of course will be increase. Okay, will be increase. Alright, the next one. So diagram 3.1 shows a spring is compressed by a steel ball of mass 0.5 kg with a force F until its length becomes 14 cm. Okay, so diagram 3.2 shows the steel ball move in opposite direction after the force is removed. Okay, so the first question is what does it mean by a spring constant? Okay, so this one is actually you got from the formula. Okay, sorry, from the formula. So F is equals to Kx, right? So K is actually is F over X, right? So the ratio, okay, the ratio of force, okay, of force applied to the spring, okay, to the extension of the spring. So X is the extension, okay. So just use the formula here, but you have to remember not all the meaning you can just simply use the formula, right? Okay. Okay, the next one, using the for information in diagram 3.1 and 3.2, calculate the elastic potential energy. So this one we use E is equals to 1 over 2 kx. Okay, why I didn't use E is equals to 1 over 2 fx? Okay, you can use it also because already give the F here, you can change it to F here, right? 0.5 times 10. But since they give you also already give you the K here, right? So you can straight away use the half kx square. So if you use here, you can have to change to Newton first, right? And then you can use half equal to fx. So this one you don't need, you just straight away use the spring constant, half kx square. So half k is 20, already given the question. X is the compression. So the compression is uh, 13 minus 14. So you got 16, but change to meter, okay, 0.16. So you got 1.6 joule, okay. You can use this formula too if you want, but you need to change to Newton, okay, for the mass, okay, or use this one also, okay. Right, the next one, hmm, okay, the velocity of the the velocity of the steel ball, okay, when a force F is removed. So based on the principle conservation of energy, right? So the energy only can change form, okay. So the elastic potential energy, we assume that elastic potential energy, okay, is same as the kinetic energy. Okay, because you want the velocity here. So we learn the formula. Okay, the formula for energy, right? That has the velocity is a kinetic energy, right? So elastic potential energy is equals to kinetic energy. Okay, so elastic potential energy we already calculate, right? The question before. Alright, so 1.6. So half mv square. So this one already given the mass 0.5. And then you calculate, sorry, so it's not 1.6. This one is v square. Okay, so v, sorry, not v square. I already calculate. Okay, so v is 2.53, right? V is 2.53. Alright. The next one, state the principle used for diagram 3b2. Okay, so this one we use the principle of conservation of energy. Right. Okay, the next one, diagram 11.1 shows an aeroplane is moving in the air. So the aeroplane moved due to the principle of conservation of momentum. So state the principle of conservation of momentum. So the total momentum before collision is same as the total momentum after the collision. So remember, must have the word total. Okay. So this is the answer for 11A. Right, the next one, diagram 11.2 shows the structure of the jet engine. So this one you have to explain the 4 marks question, the explanation. So explain in terms of principle of conservation of momentum, how the jet engine is working. Okay, so you have to explain the process. Okay, so the first one you have to say when the air is mixed, right? It's mixed with the fuel, okay, in the combustion chamber. Okay, so it will mix here. So there will be a combustion, there will be a burning process occur here. So when the burning process occur here, so they will ejected the velocity, the hot air, okay, in the very high velocity, okay, here, right, and then it will produce the large momentum backward, okay, produce large momentum backward, backward. Then according to the principle conservation of momentum, the same magnitude of the momentum will be produced but in opposite way. So it will go upward like this. Okay, it will go forward like this. Okay, so the air will mix with the fuel here in the combustion chamber. Okay, produce the high, okay, velocity of hot air. So the hot air will go this way. Okay, and then with a high momentum, because you know P is equals to mv, right? So when the velocity is high here, okay, means the momentum also will be high also, right? And then according to the principle of conservation of momentum, there will be a momentum, okay, that move in the opposite direction, okay, with the same magnitude. So we will move here. Okay, so this is the explanation how the jet engine is working. Okay, all right. For the next one, okay, you have to choose. Okay, you have to choose. Okay, which which of the part in the jet engine, okay, that suitable, that will can function efficiently. Okay, so this is the comparison. So whether the air intake should be small or big opening, okay, the blade whether iron or titanium, and the size of the combustion chamber whether should be small or big, and also the opening, okay, whether should be small or big. Okay, so 4. Right, so let's see the first one. So should be big opening for air intake, so more air can be taken in. Okay, and then the second one should be titanium blades, okay, because titanium is very strong, okay, and never rusty. And then the big combustion chamber, so more fuel can be burned. So when more fuel can be burned means there will be more hot air with very high velocity will be released. Okay, so mean you produce bigger momentum. Okay, and then next one should be at the back here. Okay, where the hot air is released. Okay, should be smaller opening. Okay, so small opening means the high velocity. Okay, high velocity means bigger backward momentum. Then of course the last one you have to choose. So I choose S. Okay, so copy back all the characteristic here. Okay, so please answer in this kind of table. Okay, right. The next one is the calculation, right? So the aircraft has a forward thrust of 1 times 10 power of 6. Okay, the mass of the aircraft is 4 times 10 power of 5. So calculate the acceleration. So this one you just simply use F is equals to ma. Okay, so F is the forward thrust here, 1 times 10 power of 6. Okay, and then the mass is 4 times 10 power of 5. Okay, and then you just divide. So you get A is equals to 2.5 ms negative 2. Okay, and then for the next question, because calculation is questions usually involve have 5 marks. Okay, so and it's question number 10 and number 11 I think. Okay, sorry, number 11 or number 12. Okay, and then the aircraft must reach a speed of 85 ms negative 1 to take off. So calculate the minimum length of the runway needed for this aircraft. So use this one, you use the equation of motion. Okay, so v square is equals to u square plus 2as. Okay, so the v square is actually the final speed, right, before it take off. So 85 u, okay, we assume it's stationary before it's moved. Okay, and then 2as. So A is actually already find from the first question here, 2.5. Okay, so you just put A is 2.5 and then S is the length you need to find. Okay, and then you use your calculator. So you got S is 1445 meter. Okay, right. So next one. So diagram 2 shows a goalkeeper, right, wearing a soft thick glove to catch ball during a football match. So what does it mean by impulsive force? So impulsive force is the rate of change of momentum. Okay. So this is impulsive force, rate of change of momentum. So let's say it asks you what is the meaning of impulse. So impulse is the change of momentum. Okay. Alright, next one. A ball of mass to 0.2 kg move with a velocity 20 ms negative 1 when it is caught. So calculate the impulsive force acting on the globe when the time of impact is 5 times 10 power of negative 2. So this is the formula for impulsive force, right? mv minus mu divided by t. So let's say in the exam, okay, in SPM. So let's say you have to write the formula. It don't just simply substitute it. Okay, put the formula. Okay, sometimes you can still got marks, right, for the formula. Okay, so please put the formula, what formula you use, okay, in your answer. Okay, and then after that you can substitute it, right? Okay, so 0.2 times 20, right, minus 0.2 times 0, we assume the ball is in stationary, okay, and then the times already given, so you got the answer is 80 Newton, okay, 80 Newton. If you're not sure about the unit, then don't put the unit, okay, if you're not sure. Okay, the next one, what happened to the impulsive force if the goalkeeper wears a hard glove to catch the ball? So give a reason. So of course the impulsive force will increase, okay, because of the time of impact will decrease, okay. So it's a relationship here, right? If the time of impact is decreased, the force will be increased. Okay, if the time of impact is increased, the impulsive force will be decreased. Okay. Right, next one. So this is the essay question. So diagram 9.1 and diagram 9.2a shows two identical springs are compressed by two different toy car at the same compression distance. Okay, diagram 9.1b and diagram 9.2b shows the position of the cars after the compression force is released due to the elasticity of the spring. Okay, the first question, what is the meaning by force? So force is pull or push. Okay, pull or push. So that's the meaning of force. Okay, the next one, using a diagram 9.1 and 9.2, you have to compare the shape of the toy car, air resistant, and also the distance moved by the toy car. So relate the shape with distance moved by the toy car to make a deduction regarding the relationship between the distance moved and air resistance. So 5 marks, so means 5 points here. Okay, so first one we compare the shape, right? So the shape here you can see the shape, this one much bigger than this one. Okay, so the shape of the toy car for diagram 9.1 is bigger. Okay, and then the air resistance for diagram 9.1 is also higher. So that's why cannot move further. Okay, compared to this one. Alright. And then the next one, the distance traveled by the toy car for diagram 9.2 is further. Okay, 9.2 is further compared 9.1. And then the next one, the bigger the shape of the car, the closer the distance moved by toy car. So means the smaller the shape, okay, it will move further, right? And then the last one, the closer the distance move, the higher air resistance of the toy car. So that one is correct. So if the air resistance is higher, okay, so the closer the toy car will move, okay, compared to 9.2. Okay, so please make sure if asking you okay about the comparison 5 marks, make sure you got 5 points here. Okay, and put it in this point form. Okay. Okay, for B, right, diagram 9.3. Okay, diagram 9.3 shows a car, right, moving with a constant velocity on a road. Okay, so mark and label the forces exerted on the car. Okay, so the first one is the forward thrust. Okay, label and name it. Okay, and air friction, and then frictional force. Okay, so you must put the frictional force at the surface of the road here. Okay, so this is how you mark and label the forces. Okay, right. Next one. So this is the last question. So you are required to give some suggestion to design a Formula One racing car which can travel faster. Okay, using the knowledge on motion, forces, and properties of material, explain the suggestion based on diagram 9.4. Okay, so this one is actually you can give more than 5. Okay, you can give more than 5. Okay, 5 characteristic. Okay, the when I mark, I will choose the correct one. Okay, even in SPM also you can give more than 5. Okay, let's say you have a 10 characteristic, so give 10. Okay, then the teachers will choose. Okay, which one is correct, but make sure it's a logic thing and it's like can be explained through physics. Okay, so the first one is a low mass, high acceleration. Okay, and then the material should be low density, so it will be lighter, and smooth surface of the car, reduce frictional force. Okay, and then wide tire. Okay, so more stable. Okay, and then have spoiler, increase acceleration. Okay, so if you have any other characteristic that you think is correct, you can ask later. Okay, you can text me. Okay, whether it can be accepted or not, right? So maybe the shape of the car. Okay, inverted aerofoil. Okay, inverted aerofoil reduce air friction also can be put in the answer here. It can be accepted as the answer here. Okay. Hmm. Other characteristic. Hmm. I think maybe no. Okay. Maybe if you have an idea, you can ask later. Okay. Right. So I think I stop until here. Okay. So on Friday, we continue for paper one. Okay, we continue for paper one. And then I have like there's some people, okay, some student ask about the paper two. Okay, for paper two there will be no chapter 4 question, electronics. Okay, so there will be no electronic questions will be asked in paper two, but for paper one you still have chapter 9 chapter 4 question, the electronics. Okay, so means for paper two only until chapter electromagnet. Okay, and then for paper one until chapter 9. Okay, even no essay for chapter 9. Okay, so maybe you can prepare. Okay, you can prepare. So I guess I stop until here. Okay, thank you class. So see you on Friday. I will put the